Good morning. Oh, music's so loud. There we go. All right, good morning. Today we're doing something a little different. I have no idea if that's going to be interesting to watch. Probably not. So here's my sales pitch. I am going to be working on, let me just pull that up here for you guys. I'm currently working through this nice little online book, Crafting Interpreters, where you're basically step by step writing an interpreter for a made-up language by the author. And so in the past few days, I've gone through all of this here. So starting with, let's see, scanning the source code into tokens, then representing that into and parsing it into an abstract syntax tree, then evaluating that, and then adding state, control flow, so if statements, while loops, stuff like that, and functions. And yesterday I did this chapter 11, resolving and binding, which the purpose of this, you're not really adding any new feature to your interpreter or anything. You're kind of plugging a hole. In the past, in chapter 10, you're introducing functions, and along with that, you're kind of creating a leak, if you will, in your scoping and the way the interpreter deals with scope. And okay, let me illustrate that. The book does it actually pretty well. Here's an example. Let me zoom that in a little bit for you guys. So, oh, look at that. That's neat. Okay. So here is a simple piece of code, and that's in locks. That's the made-up language, which is very similar to, I would say, JavaScript. And so what would you expect to happen here, right? We're declaring a variable A in the global scope. We're assigning the value, a string of global. Now we have a block statement here, and we're declaring a function that we call show A, and in that function's body, we print is a kind of a built-in function. Well, technically a built-in statement, I guess, but whatever. It prints to the console. And so function A prints, function show A prints A to the console. A, at this point, what do you think? A has the value of global, right? Now we keep going. We call show A, so we're expecting to see global in the console at that point. But right after that, we're declaring a new variable, A, and a value block. Now, what do you expect is going to happen when we call show A? Well, in JavaScript, and I think most programming language, you would expect it to still print global, right? Because function show A was declared here, and the value of A at that point is global. So even if you create a new variable A, which is block scoped here, right? It shouldn't be included in the body of that function. Well, whatever we did in the past chapter, in chapter 10, in trying to make it work with functions and closures and stuff like that, we broke that. We broke that. Now it would print global, and then it would print block. So that's not what we want. So I've gone through this chapter, which is quite long, and implemented all the code changes that are suggested here. Mind you, all of this you're supposed to follow along in Java. I decided to do it in TypeScript just for fun, and it's a pretty easy translation from Java to TypeScript. Syntax is very similar, so it's been pretty easy to do so far, and I haven't run into many problems doing that. Now, though, after doing all these changes, something broke. Doesn't work. Let me show you. Let's see. Let's just do. First, let's just make sure that we transpile our TypeScript. Okay, and then npm start. I've got a little test file here, and actually, okay, here you go. This is the particular case I was just showing you guys. Let's see here. Okay, good. So if I do npm start, what did I call? Okay, so I think it's just. I think I just need the test.blocks. I think. Yeah, that's right. Okay. So it runs the file through the interpreter, but it prints nil nil. So we've got a problem, right? That is not the value of A, that's for sure. You'd expect it to be at least global and block or global and global, but now it's nil nil. So something we did broke the thing. So debugging, that's what this session is going to be about, trying to figure out what's going on. And I have an inkling, like I have an idea of where the problem could be. The way the scoping works, since our most recent changes to the code base, is that we're basically doing okay, let me show you. Now this is like the main class, the locks class. This is what you actually run when you call in from the command line. And what we're doing, so run is the main function here that does most of the work. So see, it's pretty well organized. You run the scanner, which turns here. Okay, so you run the scanner, which turns your source file into a tree of tokens. And then you run a parser that turns. Actually, that's not really a tree, is it? I haven't played with the scanner in a while, but anyways, in the end, the parser takes in the tokens and parses that into a syntax tree. And then you take that, and this is what we've added right here. Whereas before we'd go straight into the interpreter. Now we've added a step, a resolver, which is basically going through your static. Well, it's going through the syntax tree, but it's not actually running it. It's not evaluating it, I guess I would say. It is simply looking for variables. That's my understanding of it. Anyways, it's simply looking for variables, and it is kind of building a the way he does it. It's a little complicated to explain, but you're basically going through it looking for local variables, and you're storing in the interpreter the distance between every time you see a variable and the distance in terms of scope levels of when it was declared, right? And that's kind of the way he gets you to deal with scope in the book. So I think there's a problem either in when we add stuff to that local's map that's supposed to keep the distance between the declaration of the variable and the use of it, I guess you could say. so either the problem is when we're calculating that and inserting it into the map, or so that would be happening in the resolver, or the problem could be in the interpreter when we're pulling from that local's map and trying to access it. And I don't know. That's what I need to figure out. Okay, so first thing, so we're not throwing any errors or anything like that, right? Let me just get rid of all my breakpoint. Yeah, let's run it in debug mode just to see if we have any exceptions that are maybe being caught but could tell us anything useful. Okay, so it just runs, no problem. We print nil. So the question is, why do we print nil? So let's start by going in our interpreter and finding the print statement, visit print statement. I think it would, did I pass it? I think I did. Here it is. All right, since we're printing, right, that would be a starting point to see what's going on in here. We're printing a value, and now our value apparently is nil. Nil is Lox's equivalent of null or undefined. If that's been one of the fun things to deal with doing this in JavaScript TypeScript, because he uses null quite a bit in the book, and I end up using both undefined and null. And anyways, it's not that big of a deal, but okay, so let's start with this, see what we get. Boom, boom, boom. Okay, so now I wonder if I could, do I have my Lux file for easy reference, maybe in a separate pane? Yeah, let's do it like that. Okay, so the first print statement that we find is here. Now we expect A to be global at this point. What is it though? This interpreter print value. Oh, well, we gotta evaluate it. So let's just run over it for now. Yeah, so value is undefined. See, that's our problem. And now as we go into the stringify, if it's undefined or null, return nil, because that's the proper syntax for Lux. And that's where we get our nil from, see? So now we know the problem is, if we just step out, that this evaluate our statement expression, it evaluates to undefined, when we're expecting it to evaluate to global. So let's just run this thing again, and this time step in. Okay, step into our evaluate. Evaluate returns okay. We need to use the visitor thing back here. Visit variable expression. Okay, there you go. Because the expression, wait, how did we end up with an expression here? Weren't we? Step back up here. Oh, I could have just used this. I'm still getting used to the debugger. Getting better at it though. Okay, let's just rerun this. So this evaluate statement dot expression. Okay, and our statement here is an expression, you're right, in the variable expression, which, let's see. Aha, okay. Well, it's a, and that's the token, okay. Lexeme is a, literal is undefined. Now, is that normal that it's undefined at this point? Perhaps, right? Because technically evaluate would be the one, maybe, to, I don't know. Can't remember how it deals with it, but let's go in. Let's try to figure it out. Okay, we do this, we do that, blah, 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 end up in visit variable expression. All right, now look up variable. Now that, we're in the interpreter still, that is this function here. And the purpose of this function is to look up in your locals map. You can see it's a map here. Locals map to see if you can find that variable. So the first thing you do is look up your expression in that map. If it's there, great. It means it's a local function, local scoped variable, I guess. And you get the distance between the current scope and, technically, anyways, the current scope and the declaration, I think, the variable declaration, yeah, or assignment. Not sure. Well, technically, which, yeah, the assignment, right? And let's see here. Well, let's step in. All right, so this locals, we've got 3 entries in local. Yeah, let's take a look at that. Interpreter, locals, we've got 3 entries. What are the entries? 3 variables, and they each have a value of 0. Now right away that seems wrong. I don't know. Let's see. What's the first one? Okay. So the first one is a literal undefined. The second one is show a, so that's right. That makes sense, right? Because this would be a local here, right? And then the next one is show a again. So we've got 2 show A's and 1 A. Is that what we expect to see in there? I'm not quite sure. Could this A be this here? And the show A would be, I honestly don't know. Well, no, technically this is where we're at in the, no, this is where we're at in our interpreter, right? Because if we're at the point where we're trying to print, it means we have called this function. Let's keep going, see if we can understand a little bit better what's going on here. So are we going to find our expression here in that map? Our expression is the A. Technically this one here, right? This one here. And let's see, can you guys see the, just barely, eh? There you go. Okay, so we go in, and apparently we've got a distance of 0, so we did find it in the, and where the map is storing the actual object as its key, right? Yeah, it is. Okay, so it's looking it up by reference, and it found it. And then what? If the distance is not undefined, so if there is a distance, yeah, return this environment, get at distance name Lexeme. So we're looking, let's see, let's go in there. Get at returns this ancestor distance, so this would be this function here. Dot values that get, looking for the name A. All right, so it's going to go in to the environment, our current environment, and it's going to look in each environment in the stack of environments. So right now we're supposed to have, logically, we have this environment, right? This is where we're at. Or is this where we're at? Let's see. Well, we called this, but calling this should have taken us in the body. Right. So let's take a look. Our environment is this, and it has no values, which would be correct if the environment is in this here. There's no declared variables in there. There's no variable declaration, and that's what the values map, I think, would keep. Yeah, but it has an enclosing, which would be the block here, and that one has one value, and that value should be our show A. Yeah, okay, so this works. Show A. And that enclosing has its own enclosing, so that would be the global scope, which has two values. What? Should only have one. Should only have the A that has global in it. Oh, clock. Yeah, that's kind of a built-in thing. Okay. But it does have the A. See? A. And it has the proper value too. Global. Now, we're expecting here to go, the behavior I would expect at this point is to go into that environment, the global environment. So go into our current environment, go, okay, I need to go into this one, and then I need to go into this one. But obviously that's not what it does, because we know we've passed this distance of 0. So it's just going to go and return our current environment. Yep, see? And in that current environment, our values map is empty. Let's see what happens with that. Get back to get A, so we're going to be returning, okay, we're trying to get the values from this. So, and our environment right now doesn't have an A in its values map. So that should return undefined, and there's the problem. In part, anyways, right? Let's see. Return value undefined. That's right. It's like, oh, there's no, There's no a value. There's no a variable in that scope. Well, duh, but that's not where you're supposed to look. So return. So now we're just returning, right? Oh no, what's going on here? This environment get at. Was that where we were? Yeah, that's what we were in. So we're unwinding here. And we're going to be returning undefined again. Yeah, because we're returning what we just returned. So yeah, return value undefined. We're getting back up to our visit variable expression, which will also return the result of this, which is undefined, I think. Yeah, going back up the stack all the way to evaluate, which is also going to return undefined. And we're back up to our print statement. Okay. So the problem is the distance. We shouldn't have a distance of 0 when we look up that that print A thing. Now we see that it's stored in the global environment properly, so that's fine. So how does it end up being stored in our locals? It shouldn't get stored in our locals, because we did find it in our locals. We did a lookup when we look at, let's see, what were we in? It was the print statement, and we evaluated, and we visit variable. My expressions here. Visit expression statement, statement.expression. Where were we? Oh, here. So this here, when it looked up the local variables for our expression, which was the the variable A, it found it in there. I'm thinking it shouldn't have been in there, right? It shouldn't have been able to find it in there. So we're going to need to look at what's happening in the resolver. How does it deal with this here? Like, does it somehow store this in the locals? It shouldn't. So let's see. Let's go in the resolver. And let's get it here. Okay. Resolver, resolve, then you, okay, the private resolve. Okay, well let's put our breakpoint here. Get rid of this one for now. Run this, see what happens. Step by step as we're resolving this thing. All right, here we go. So statements is an array of var and block. So remember, we're going down the syntax tree. So at this level here, so the global level, the syntax tree has two things in it. it's got a block statement and it's got a variable statement. Is that right? Am I understanding this correctly? Yeah, right? So we've got a var token that we need to do something with it, and we have got a block token that we've got to do something with it. All right, so let's do something with it. So let's go and resolve first our var. Okay, cool. Which should take us to this function here. It's a var is a initializer value global, so that's the literal, and that's the name, which is the token itself. Let's go in. So it's an expression. Yeah, var is an expression. So expression accept uses the visitor pattern thingy. Gets, why does it open in there? I don't care. Okay, now this is how we deal with this. We've got our var, which is this. We've got a var statement here. The initializer is the literal global. The name is A. Okay. So now, if we go into declare, that's the first thing we do. Okay. This dot scopes dot length is equal to 0, which should be true at this point, right? Because we're in the global scope. So there shouldn't be anything in our scopes yet. Let's make sure that's correct. This dot scopes is an array of length 0. Good. So this should just return at this point. Should just return, and we should just ignore this because for global stuff, we don't deal with it in the resolver, we just deal with it in the interpreter in a dynamic fashion. So good? So far so good. Now, if statement initializer, we do have a statement initializer. That's our global literal here, string literal. What do we do with that? We get in, we resolve that. What does that do? Get back here. Okay, it's a statement. We do the visitor thing. The literal expression, return null. Right, because we don't care to deal with that information at this point. We're just in the resolver. We're not evaluating it. Okay, good. Keep going. Now we're out of the resolve. We get back to, oh yeah, we're not done. We declared it, now we define it. But we probably are going to just skip over that as well and ignore it because it's in the global scope. Right? There you go. Same behavior. We're checking to see if it's in the global scope. If it is, we just return. There you go. Boom. So at the end of this pass, just return, boom, we're done resolving. Yeah, good. So at the end of this pass, basically nothing happened. We found, let's get back here, we found a, oh, I gotta make some room for you guys to see a little better. There we go. Okay. So we found the variable A. We figured it was in the global scope, so the resolver didn't do anything with it. It's like, fine, it's in the global scope, whatever. The interpreter will deal with that. And the proof of that is that scopes, I can't, oh, for some reason I can't hover over it. But if I look at the local closure, and I look at the, no, not the closure, the global, nope, it should be in the closure. Function type, locks one statement. Oh no, it's in the block. I'm in the resolver right now, yeah. So scopes is still 0, yeah. Okay. Okay, so let's resolve our next node in our tree, which will be the block. Right, the statement is the block. And the block statement is an array of 4 statements corresponding to this. The first statement, which is a function declaration. We got another statement, which is a function call. We've got another statement, which is a variable declaration, and another statement that is a function call. These are the 4 that we should see in there. And let's see. So first we've got our function. Cool. The name show a, so that's good. What does it have in its body? It's got a print statement, or expression. No, print statement. Okay. Which itself has the variable expression containing a. Cool. So this all seems to be, what did I just do? This all seems to be wired together properly, right, so far? Then we've got a function call right here. Then we've got another var here. And we've got another function call. So our syntax tree seems to be, so far, all good. And there's no reason why we would expect it to not be, because it was working fine before we did all these changes and we didn't change anything to the parser. Yeah, okay, so let's go in there. See how it deals with this stuff. Now that's going to be interesting because, yeah, let's see. So first expression we're going to be dealing with is, oh, our block itself. Yeah. It's a statement, yeah. Okay, oh, now that's interesting. Yes, now we start dealing with scope. Wait. Yeah, that's right. So begin scope. What is that going to do? Let's see. Basically pushes an empty map onto our scopes array, letting us know that we're now 1 scope deep. If we look at the scope.length, it'll return 1. Now that we have a scope, we resolve our statements. So that'll just take us back to this here. We're going to use this thing here. We go through all of the statements. The first statement we're going to be looking at is our function declaration, I'm guessing. Step in one more, yeah, that's right. We resolve that, so let's go in. And okay, it figures that it's a statement. Go in, use the visitor, and now we're into our visit function statement thing. What do we do? Same principle as the var declaration, the variable declaration. We're going to declare and define in 2 steps. But this time, since we're not in the global scope, we're actually going to do something with it. Right? this should return 1 here. So there you go. So we're not going to return here. We're going to keep going with our declare function. Now what do? We grab the scope from the scopes array. How do we do that? We look at this scopes.length and we take 1 out. So basically we're saying let's get the innermost scope. If we were like in a situation where there's a lot of nested scope, we would want the current one, right? So that should return well, basically the only scope we have, right? Should be an empty map for now. Let's see, scope is oh, is it entries array 0? Wait a second. Entries array 0. Huh. Is that an internal thing for map? Internally it uses an array or something. I didn't declare any arrays, right? And it's empty anyways, so okay, well, whatever. Now what do? Okay, we check to see if the name is already in there, because if it is, we're going to throw an error. We're going to say, look dude, you already say variable with this name already declared in the scope. But that's not going to be the case here. There we go. So what do? We actually set that variable declaration. I'm going to say variable is a function, right? A function name declaration into that scope map. And name lexeme is show a. So we're just going by name. And false. And that's to say that we didn't initialize it yet. It's declared, but it's not initialized yet. We're not dealing with any value. Okay, so let's go and do that. This should bring us back to our visit function statement, where we now will define, but let's just make sure that we're following along. Our scopes here should have 1 map, right? It does, and that map should contain, oh yeah, it's like an array, I see. It should contain key show a, value should be false. It is false because it is declared, but it's not initialized. And now that's what we're going to do. We're going to define it. Going to go in. This is going to return 1, right? So we're going to keep going with this. Now we're getting this.scopes. We're getting the latest scope, the current scope, and we're setting our name.lexeme to true. So we're just basically saying, so I guess, yeah, the reason we're doing this in 2 steps is that just so we can detect if we already tried declaring it, and it would throw an error if we had. And so this should be set to true. We can confirm that by looking again at our scopes map. Entries now should be set to true. Yeah. Okay. So far, so good. We then get out of that function. Oops. No. We have to resolve the function. Did I miss something? I thought we were done. Let's just go. We were in visit function statement. Oh yeah, okay, we declare, we define it, now we have to resolve it. That's what we're doing now. Alright, so we're resolving this. Enclosing function, function type, this current function. Okay, I guess this is to deal with closures. Now the enclosing function is equal to this current function. What is this current function? 0. Resolver has a... oh, it does. It does have a field called current function. And it's set at the beginning to none. Okay. Let's get back in here. This is using an enum, that's why we're seeing 0. 0 is none, 1 is function. Okay, and then this current function equals type. Right, type equals function type. What did we pass into this thing? We passed in type 1 because it's a function, right? So cool, now we've changed our current function type to 1 and our enclosing function type to 0, which I guess is meaning to say, well, right now, this is our body, this is what we're looking at, I think, here. We're about to, anyways. And our enclosing function is none, right? The enclosing is the block, I guess, which isn't a function. But now we are in a function. That's what we're saying, I think. Okay, now we're beginning a new scope. Okay, this is interesting. We're beginning a new scope. So this should push a new array, a new map, sorry, into our scopes array. Done. Let's just confirm that this is the case, right? So now our innermost scope has nothing in it. The other one, though, has our function name, show A. So we're now in this scope. This is basically what this is saying. This is the scope we're in. If we look one scope higher, this is what we have in there so far, if I understand this correctly. So now we look at the parameters, the function parameters, and there are none, so this should be pretty quick. Param, boom, we're done. Yeah, okay. And now, resolve function body. The function body, as we have seen, is composed of the print statement, which has an associated variable expression to it, which is the A. Now this is, we're getting close to what we're really interested in. So resolve, there's only one statement in there. The statement is print, so that's what we're going to be dealing with, right? Statement is print, that's right. So let's resolve that. This should take us to this. It figures it's a statement, goes with the visitor thing, and we've, okay, visit print statement. Now, how do we resolve the print statement? Well, we look at the associated expression, and we resolve that. So you can see this is like a whole tree kind of thing. It's pretty cool. It's kind of hard to wrap your head around all of that, but it's really clever. Like building a mental model of this whole thing is not trivial. And that's essentially what we're doing here, step by step. Okay, same thing. Now we're dealing with an expression. Get the visitor, and we're in visit variable expression. Okay. If, now let's take a look, because this is important here. We're dealing with this here, right? And we've been printing nil instead of global for this. So this might be where the problem is. If this dot scope dot length, in other words, if the scopes array is not empty. Now let me just make sure that this corresponds to the code that was in this. We are in visit variable expression. Yeah, let's try to find that instead of scrolling. Visit variable expression. That's the one. Okay. If scopes.isEmpty negated, so yeah, because we don't have a isEmpty on our JavaScript array, so I think that's why I implemented it that way, which comes to the same thing, right? If length would be 0, the condition would be false here. So that's about the same thing. And this dot scopes dot length -1, so the last one in the scopes, so the most current scope, the inner scope, dot get expression.name.lexeme is equal to false. So if we have scope and the inner scope does not, or does have, has, okay, if it has the expression but it's set to false, so it's not initialized. Cannot read local variable in its own initializer. I see. That's okay. Let's just make sure that we did that properly, right? Okay, that's why I did it that way. We don't have a peak. Oh yeah, because this is using an actual stack. There's no such thing as a stack. In JavaScript, you just use an array. Although I do plan to make my own implementation of an actual stack, because it's kind of a, like when we really do want to use a stack, like, and only use a stack in the usual stack functions that you would have, using the JavaScript array can be a little bit of a pain, right? You don't have these nice isEmpty and peak, which allows you to take a look at the last element in the array, or the element on top of the stack, without actually popping it off. So there's a nice scopes.peak, and we have to do scopes, now get the index, that is the last one, you know what I mean? It's just, but anyways, it works. So scope.speed, get and boolean false, right? Because remember, our scopes array contains our scopes, which are maps, and our maps contain entries that are set to either, and our entries, the key is basically the variable names, the identifier, I guess would be the correct term, and the value is either true or false, false being that they were declared but not initialized or defined, and true is that they were declared and defined in that scope, I think. So now we're looking in our current scope, and our current scope is this here, right? So we shouldn't even find the A. Shouldn't even be there. So this should evaluate to false. Like this if statement should evaluate to false. This evaluates to true, but this should evaluate to false. Therefore, the whole thing, since it's an end, right? It's an end, yeah. Should evaluate to false. There you go. So we skip over this. Now we go, all right, let's resolve a local. And again, let's make sure that we've didn't miss any behavior. Resolve local expression name. That's what we're doing in our code here. Expression name. Good. Let's get in there, see what happens. All right, now this might very well be where the problem is. Let's find out. See how we're crossing over? We're in the resolver right now, but this is where we're crossing over into the interpreter. And what are we doing? I can't remember, so we'll just follow along. Now it's interesting here that I don't seem to be using name. Huh. Let's get, so I might be missing something in here. Resolve local token name. Yeah, name.lexeme. Okay, so I think might have missed something here, and that could be the explanation. Oh, I definitely did. Let's put that side by side. I don't know if that's gonna, oof. Okay, hold on. Let's try to fix this. Split the editor, no. Close all, no. Show opened editors, no. Okay, maybe if I just close them, yeah, okay. Do this so you guys can see. Alright, so I'm supposed to, oh, I lost my, where'd it go, where'd it go? No. Here it is, okay. So 4, this is good, no problem, but oh, look at this. We are missing an if statement. Ha ha ha. Just found it. Just found our problem. Pretty sure, anyways. So if, what are we doing here? This dot scopes. Which is an array, so we can't use get, right? Wait a second. Get. There's a get on the stack. Anyways, who cares? Let's just do it. So we're basically getting I, okay. And then that's going to give us a map. We don't have contains key, but we do have has in JavaScript. And there's our name, not lexeme. Aha! Now if it has it, then, but in our case it won't have it, and that's why it ended up in there. Remember I was saying at the beginning, I'm like, I'm not sure this should be in there, I don't, and that's why it ended up in there when really it shouldn't have. Okay, simple as that, right? Let's just make sure that we've got this right. Good. Boom. 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 Let's get back. Let's get our thing here back again. We can stop this for now. Let's get our Lux file here. Okay. And let's run it without the debugger. Well, 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 look at that. And that is that's what we're expecting. We want this to print global twice. We don't want it to print block, which was the behavior before we implemented the whole scoping thing for this chapter 11 of the book. I am quite happy. I had started trying to debug this last night. It was like 11 o'clock. I was tired. I was like, oh, I couldn't make heads or tails of it. And I figured, you know what? Let's just put this off to tomorrow. And I'm glad I did. I'm glad I did. So what do we do now? I still have an hour. I thought this would take me longer. Well, we could keep going with our implementation of the interpreter. I think the next step was the class. If I go in here, classes. How cool. I haven't read it though yet. I usually prefer reading it before implementing it, right? So maybe I won't. Maybe I'll wait. Maybe I'll be a good boy and not just code stuff I don't understand at all. I'm not going to pretend that I understand 100% of everything I'm doing through this book. Well, actually, most of it. And as I'm coding it, like I read, the way I do it is I read the chapter first, try to get a sense of what's going on. Then I code it. Then I debug it if it doesn't work, and it happens. And what we just did, the whole process of like going through every step, really helps in building that mental model of what we're actually doing in the interpreter, because it's quite complex, right? But it's not out of reach in terms of complexity. It's just you have to wrap your head around it. So all right, I think then what we're going to do is go into our last crusade. First. So that's all it took. Let's one line fix. I'd forgotten to. So bug fix, or let's just fix bug with scoping. Finish chapter 11. Chapter 11. What was the name of chapter 11? Resolving and binding. Resolving and binding. Alright, let's push that to GitHub. So we could do a little bit of work on our last crusade puzzle, which is a quite complicated one. I did think about it a little bit yesterday, and I think I want to change my implementation and just go ahead and use a graph. Okay, let me just get in there first. Coding game. Good. Last Crusade 2, that's correct. Let's just get into the correct directory. Okay. Run my dev thing. Okay, and then tell coding game we want to use our external editor. It's already got the right file, so let's do that. Okay. Now, Let's just quickly take a look at what's going on here. Function input. Yeah, it started. You know what? We're going to completely scrap this. And we're probably going to end up scrapping this too. Because what I'm going to do, okay, let's just think about this. What I'm thinking that we're going to, right now, my solution was really kind of plain, rudimentary. I would just look ahead every time. Every turn I would look ahead and see what was in front of me and rotate it if I felt the need to rotate it. And that's too short-sighted a way of doing this. And it's definitely not going to work as we progress through the different test cases because there's too many variables and possibilities through the maze. So here's what I'm thinking. I'm thinking we should make a graph of the tunnel system. Now the thing is, let's see, right, how would we make a graph if it doesn't connect? Ha. Right, for instance, if I wanted to make a graph of this here, that's the beginning state. We're starting here. So that's our first node. It connects to this one. That's our second node. This one connects to this one. That's our third node. But actually, this doesn't work, right? So what do? Do I construct the node, the graph first? Going through it, trying to find, rotate it until it works, and then I think I'm gonna have to think about this some more. This is gonna require some thinking, which I don't want to do on screen because this could take a while and is gonna end up being quite boring. That's the thing with these hard puzzles, they're quite fun, but I find for streaming sometimes, because sometimes you really have to stop and kind of like really think this through, make a mental model of the whole thing, and maybe jot some stuff on paper, and it makes for some big lulls when you're streaming live. So I might just put that aside in this case and just think about this before implementing. But my idea was really to make a graph, but now I'm wondering how do I, so as I'm making the graph, as I'm going down the graph, I have to, when I get to a state that's not valid, I guess, I have to rotate and then see where that leads me to the next one, until I get to the exit. Or do I make the graph be the entire state of the thing and then rotate? Oh no, that would be crazy. That would be combinatorial hell. Yeah, I really have to think about this. So we're going to skip that for now and maybe find something a little lighter to work on And I think I have an idea of what we could do. I think we could, boom, do one of our exorcism exercises. Where am I at? This is where I'm at. Have I done these? I've done all of these. I don't think I've done this. In progress, in progress, progress. Unlocked. Let's do this. Perfect numbers. Determine if a number is perfect, abundant, or deficient based on Nicomachus, an old dude, classification scheme for natural numbers. The Greek mathematicians Nicomachus devised a classification scheme for natural numbers, identifying each as belonging uniquely to the categories of perfect, abundant, or deficient, based on their aliquot sum. Whoa, we're going to be doing some learning. The aliquot sum is defined as the sum of the factors of a number, not including the number itself. For example, the aliquot sum of 15 is 1 plus 3 plus 5. Yeah? Right. Factors are, if I remember correctly, numbers that are divisible, that can be divided by, no, that can be, well, so 15 can be divided by 5, it can be divided by 3, it can be divided by 1. So those are its factors. Yeah, and it can also be divided by 15, obviously, but not including itself. So it's the sum of the factors. Do I have this right? Aliquot sum is defined as the sum of the factors. Yeah, okay. So a perfect aliquot sum equals the number. Oh, interesting. Okay. So 6 is a perfect number because, okay, I get it. Abundant is when the aliquot sum is bigger than the number, and deficient is when it's smaller. Prime numbers are automatically deficient. Implement a way to determine whether a given number is perfect. Depending on your language track, you may also need to implement a way to determine whether a given number is abundant or deficient. Interesting. I don't see why that would be. In TypeScript, anyways, but we'll see. So should we give that a try? I think we should. I think we should. I think we should. So we will. So let's just get out of here and go into exorcism. Right on. Now let's just get rid of that. Rid of this. And exorcism's got a nice little CLI to download the exercise. So let's use that. Perfect. So cd TypeScript. Okay. Now we need to install the dependencies. Good, and then we can take a look. Where's it? Perfect numbers. Let's look at the test file. So we're expecting a class, it looks like. and we're going to be using a static method, is what it looks like. Maybe it's already done for us. Nope, we get to implement that ourselves. If we run the tests, just see if that works. Yep, okay. So describe perfect numbers. Smallest perfect number, is classified correctly. Perfect number, smallest perfect number is classified correctly. As expected, perfect. So we need to return a string that just says perfect. Expect perfect numbers of classify 6 to equal expected. So that's going to be easy enough to implement. So let's go export. It's expecting a default export, isn't it? Yeah, it is. Export default. Perfect number. We could call it whatever we want, really. Perfect number, since it's a default, but let's mirror perfect numbers. Oops. It's got to be a class. Yeah. Okay. And we're not instantiating that. We're just using a classify static method. So classify is the method we're going to be working with. It's going to take a number. So let's just call this num of type number. It'll return a string. Okay. What is this saying? We're not using it. Yeah. So now let's just return let's just pretend we're doing something with this to make TypeScript happy, and then just return perfect. And I'll take care of our first test case. Ah, right. Well, that's going to be annoying. Okay, whatever. Let's run the test. npm test. Classify. I didn't spell it properly. Classify. Oh, I didn't make it static. Duh. Okay. Run a test. And it passes. The other ones were skipped. Let's unskip them. And run them. Well, not just all of them, but the next one. npm. Did I think I hooked this up in a way to debug, maybe? Oh, I gotta change it every time. Okay, that's gonna be a pain, but if we ever need to debug, we could. npm test. That's probably gonna fail miserably. Or no, it passes, right? Because it's still expecting perfect. And wow, this is really easy. We're going to pass this next one. Yay! Now abundant numbers. This is where this is all going to go to. And we fail because we received perfect, but we were expecting abundant. So let's do this. If number is equal to 12. Oops, 12. Then return abundant. Otherwise return perfect. And that should be enough to take care of that test case. It would be interesting if I can get through the entire thing just using a few if statements. That would be an indication that the test cases aren't very thorough. Okay. Now if it's 30, expect it to be, well, that's going to be an easy one too. It makes, okay, so if num is equal to 12, or, you know, it's equal to 30. Since the types 12 and 30 have no, what? Oh, or, I had end. Whew, okay. And we're good. Next one. It's getting stupid. But look, so far, I mean, look at that. I only have a few lines of code. I'm halfway done with all the tests, and I'm pretty sure I can just, yeah, I'm gonna get through it. Oh, it would be hilarious if I just do it that way and then submit it, you know, for mentoring, and they just see this few if statements or a switch or something, and I'm just hard coding all the solutions in there. Let's keep going. That's the principle of TDD, right? It's, you're supposed to do the least amount of work that'll pass the test. What are we? We're expecting a deficient here. Okay, now that's going to be a bit more complicated, but not all that much. We just add an if. If num is equal to 2. Then you return deficient. Smallest prime deficient numbers classified correctly, expected value to equal deficient but received perfect. Isn't it 3? It's 2. Oh. Boom. Trudging along. Let's skip ahead. We got 4, we got 32. So let's do this. We got 4. We got 32. And we've got I'm sorry, it really is the least amount of work we can do to pass those tests. And there's another one. is, oh, 1. Okay. Let's just save a little bit of time. Run all of these. Yep. Invalid inputs. Yeah, they really should find another way to test this, because it's so easy to just hard code it. If 0 is rejected, not a natural number, we need to throw an exception that says classification is only possible for natural numbers, dude. Okay, so if 0 okay. Actually, negative integers rejected, not a true number. Yeah, let's just do both at the same time. And we're going to be done with this exercise. I feel kind of dumb doing this though. Let's test all of them. Boom! TDD at its best. Look at this. It's really short too. I don't know what to do. Should I just submit this? Or should I... Well, probably at least commit this for posterity. So, solved. Let's see, solve perfect numbers using TDD. Let's share this with my fellow exorcism mentors just for laughs. Hey guys, check out my super solution to perfect numbers. Send this code here. Code or text snippet. Let's get TDD at its best. Let's tell it that it's TypeScript. Get the highlighting properly. Add a message. Used TDD, which simplest way to pass each test is to just hard code the solution. Oh, I guess this should be part of this. Edit message. Boom, boom, save changes. We might want to beef up the test suite a little to make this hurt more. Like this was so little amount of work to do. Okay. We've had our fun. Let's try to solve this. So the first thing we need to do is to get the factors, right? Because we need to figure out, let's get this thing back here. We need to figure out the aliquot sum, which is the factors of a number, the sum of the factors of a number, not including said number. Well, I haven't done one of those factors thing in a while. You know what, let's just go ahead and cheat. I know there's a bunch of them out there, so let's go with JavaScript. Factors. That's the one. It's using recursion. No, he's not. Really. I've seen some better implementations, I think. This is the exact same thing, wasn't it? Whoa, that's cool. They have it for like every language known to man. Amazing. So let's go for JavaScript or TypeScript. Would they even have it in TypeScript? That'd be amazing. No, they don't. JavaScript. Imperative or functional. That's what we want. Thank you. What? Gross. Who still uses those? Okay. Integer factors. What is that? First test? LS test? Integer factors. Well, root, mass square root, interval. this better. And it's returning an array, right? This is the this is what I'm more used to. And this here, I would have to wrap my head around that. Monadic chain bind fail. What? Dude. Let's just go with this. And we'll just well, actually, for perfect squares we can drop. What is he doing here? Integer factors, n. Let r root, yeah, int root. Close, range 1, int root, filter. Perfect squares, we can drop the head of the highs list. Turn those contrast from reverse size. Range. Really interesting, but don't want to spend my entire morning looking at this, so let's get that here. We'll just make this a, well, let's make it a static as well. Oh, let's pretend that we would want to use this at some point. Oops, 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 oops. What have I done? Static factors num number. What are we in C#? There we go. This, that, this. Using a var. For statement must be braced. Yeah, I don't know who wrote this, but this is not how you write JavaScript, dude. I think this is what goes in the for. If for, if, oh, those are nested statements, okay. So it's the one if here. We're good, okay. Tell me that. This, what are you going on about? Identify factors never reassigned, use const instead of var. Gotcha. Cool with me. I don't like multiple. Let's use this. Why would you not do it here? Let's just do that. Get rid of this. Yeah, whoever wrote this wasn't used to JavaScript. If okay, like that. Sort. Yep. Let's use our arrow function. Then we won't need this, and we won't need that. Much better. Don't care about the comment. Get rid of this. There we go. And now we get our factors. Now the only thing we need to do is get rid of our number, which will always be the last one. Well, do we need to get rid of it? Really? Maybe not. We'll see. Okay, back to this. Actually, why don't we just make this a function in the global scope? It'll be less annoying to call. It will be in a second. Now, we need to, what do we need to do? We need to sum this stuff up. So, const aliquot sum is equal to, let's get our factors, boom, number, fatters, factors. No, okay, so this will return an array. Now we take that array and we reduce. We reduce that array. We've got our previous, let's use this. We've got our previous, our current, and we've got this, and actually summing is really easy. It's just a matter of going P plus C, right? And that'll give us the sum. Yep. Okay, so then I'm gonna actually, let's do that, then reduce, just remove the number from the sum. Right, because I think, where's my instruction here? Liquid sum is defined as the sum of the factors of a number, not including the number itself. There you go, so just remove it. Subtract it, and we've got our aliquot sum, which is of that number, just so that we're really clear on that. What do we do with it now? Oh yeah, so if it's exactly the same, if the aliquot sum is exactly the same as our number, then we've got a perfect number. Yay! Return perfect. Should I make a switch? Can I make a switch with this? No, I'll keep it like that for now. Well, let's see if we pass a few tests here. There we go. Oh, we're not returning. Return. I don't know, something else. Actually, it would be smart not to test for this, because that would be the a rarer case. Perfect is the rarer case, probably, right? So let's test for everything else, and then if it's not, well, it's obviously perfect. So if sum is, you know what, let's just implement all of that. It's not complicated. We've had our fun with TDD. Let's just do this. Perfect. Aliquot sum is bigger than the number. And then we've got return abundant. If let's add a little space here, space there, get rid of the white space, get rid of the white space. What? Whatever. If sum is smaller than num, then we're looking at, what was it, deficient, I think it was called. Return deficient, yeah. Whoop. Return deficient. What are you doing here? And that's pretty much it. Alright, and then we can just, okay, let's run this. The only ones that should fail are the ones about the invalid numbers. And right, it's only possible for natural numbers. Classification is only possible for natural numbers. So let's, what were they? 0 minus 1, because negative integers are not natural numbers. So basically I can just check for that first. If number is smaller or equal to 0, yep, then just throw, actually I don't need the whole, oh yeah, they want us to use curly braces. Show, throw, what was it that we were supposed to throw? Let's get into test cases here. Okay. And let's throw that. Am I supposed to throw an error? I'm supposed to throw an error. Will this work? If I don't actually wrap it inside an error? I think JavaScript does that automatically. We'll find out in just a second. Nope, it doesn't. Reduced. What? Instead, it threw reduce of empty array with no initial value. Ah, yeah. Yeah. This actually needs to be before we try to get the... like that. Just give this a try. There you go. So we don't even need to wrap it inside of there. Pretty neat. So we've got our factors array, or not array, function, thanks to the internets. Couldn't be bothered with implementing that for the umpteenth time, although it would have been bad to do it just for a refresher. But let's see if we can clean up this stuff here, though. It's only, yeah, I don't think it's worth making any kind of fancy switch or whatever. Yep, let's just leave it like that. Commit that, so solved. Solve, perfect. Perfect. Numbers the right way. Look at us. A lot of stuff today. Fixed a bug, completed an exercise on exorcism, even had a little bit of fun with it. Okay. Well, folks, I guess that's it for me for this morning. Time I technically have 8 minutes left. I think we can cut this short. Won't have time to do anything of substance in 8 minutes. So thanks for watching. Have a good day.